So 4.4 part 3 talks about amplitude and period. And so it tells us here the graphs of sine and cosine functions and their transformations are called sinusoidal graphs or sinusoidal curves. So if you see them say that it's sinusoidal, that doesn't mean you're using sine necessarily, okay? It could be cosine as well. And so they tell you here that if you have the functions y equals a times sine of x or y equals a times cosine of x, they're going to have an amplitude of the absolute value of a in a range then from negative, whatever that absolute value of a is, to the positive of the absolute value of a. So what it is amplitude is the distance from the center of our curve, the axis of our wave, the middle of it, to either the top or the bottom. And you can identify that by just taking the absolute value of your a function. Or, I'm sorry, not your a function, but of your a value. So look at the first one there, or number 1 here. It says graph y equals 3 sine of x and y equals sine of x on the coordinate system over the interval from negative 2 pi to 2 pi. State the amplitude and the range of the function. So first, let's do y equals sine of x. Do you remember your table? Sine and cosine have a period of what? 2 pi. So that means my parent table is going to go from 0 to 2 pi. Okay? It's in even increments. So what is exactly halfway between 0 and 2 pi? So we're going to put a pi in the middle. And then what is exactly halfway between 0 and pi? 0.5 pi or pi over 2. And so what's exactly halfway between 1 pi and 2 pi? Yeah, 1.5 pi, which is 3 pi over 2. Good. Now, where does sine start at? Does it start at the origin or at the top? At the origin. So it's going to start at 0, and then does it go up or does it go down? Which way? It goes up. So we're going to go up to 1 and then come back down. So if it goes up to 1, it's going to go down to negative 1 and then come back up. So maybe that'll help you kind of be able to start memorizing that table there. All right, so if I go to graph this table, it says what, negative 2 pi to 2 pi. I better scoot my line over a little bit there. And it wants me to go all the way to negative 2 pi. And so let's see, I'm going to let it go up to 3, and we're going to then go down to negative 3. So then graph your points.
The y equals sine x, that's like the parent function.
That is our parent function, yes. Now it said from negative 2 pi to 2 pi. So once you get what's in your table graphed, then just follow your pattern. So now be careful, because look up here real quick. If I put a point here, that's not following the pattern, because this point that we're at the origin, 0, 0, is the same as this one down here at the end. Okay, so from the end we go down, so just be careful on that. I see a lot of students try to go the wrong way. Remember, it's going to be a wave. And I use different colors to help identify which one's which, but you need to label it if you don't. And does that look like a sine curve? Okay. So we probably did it right. But it also told us the graph y equals 3 sine of x. So what is that 3 going to affect? Did we talk about the a, b, c, and d yet? No. Okay, let's talk about that real quick then before we graph it. Okay, so you remember when we talked about like quadratics. And we said we had with transformations, we had y equals a times bx minus h squared plus k. And I told you it was important to know it because you're going to keep using it over and over and over. Well, I wasn't lying because we saw it with logarithms, we saw it with exponentials, we've seen it with absolute value, we've seen it with all the different functions that we've studied. Well, we also see it with trig functions. And trig functions are y equals a. And I'm going to write the word trig because it could be sine, it could be cosine, could be tangent, could be any of them, okay? So y equals a, whatever your trig function is, of b times x minus c plus d. They use c and d instead of h and k. No big deal. It's the location. B is written not really inside with x, but remember if you hit, well, we haven't really done too much, but when you hit sine or cosine or tangent on your calculator, it opens a parenthesis right here. So really it is inside with x still.
What is the C?
The C is like your H. It is your horizontal shift left or right. The D is like the K. It's the vertical shift up or down. B is just like B. It was our horizontal stretch or compression. And A is just like the A was. It's our vertical stretch or compression. Anything that's there with the X, the B and the C, will do the opposite of what it says. If it says B times, we divide by it. If it says minus C, we're going to add it. Okay? So remember, anything with X always did the opposite. Same thing here. All right, so looking at the equation y equals 3 sine of x. What is that 3 going to affect, my x or my y? It's going to affect the y because it's not with the x, okay? It's not inside with the x. So we are going to affect the y, and what's it going to do to my y's? Do I add, subtract, multiply, or divide? Multiply. It says 3 times sine, so we're going to multiply. Y does what it's supposed to. All right, right now we don't have anything with the x, so just leave x as x. So my x's are going to stay the same. I'm actually going to show you another way to do x when we get to it, okay? My x's stay the same, and all my y's are times 3. So without even graphing it yet, what do I expect to see? What is that 3 going to do to my graph?
It's going to get taller.
Yeah, it's a vertical stretch, isn't it? We know it's vertical because it's not in with the x. We know it's going to be a stretch or compression because it's being multiplied. And since it's a number bigger than 1, it's going to be a stretch. All right, so let's plot those points. All right, so there's our graphs. What did the 3 do to my graph? We said it was a vertical stretch, right? All right, so I'd already asked that actually. But look at the graph itself. Do you see where like our x-axis here looks like kind of the middle of both of them? On that pink graph, how far above the x-axis does it go? And how far below the x-axis does it go? It goes down 3 and it goes up 3, right? So that's what amplitude is. So what is my amplitude? Your amplitude is 3. Remember, it told us above the amplitude is the absolute value of A. So it's the absolute value of the 3 that was in the equation, which is 3. Now look at your graph also. So what is your range? Just looking at the graph. Range is what, X or Y? Y. How far down does it go? -3. How far up does it go? 3. So there's no breaks in between them, right? Every number between -3 and +3 is included. So we know that our range is -3 to +3, but up there it told us that it was negative absolute value of A to positive absolute value of A. Well, in that case, it's exactly what you told me. Absolute value of A was 3, so it's going to be -3 to +3. So even if you don't have a graph, you can pull that out of your equation. There. Of course, if you have a graph, personally, I think it's easier to look at your graph.